Okay, but solutions are homogeneous mixtures of two or more substances. Basically, when you mix two or more things together and it makes something that looks kind of, like one thing, that's what a solution is, right? Homogeneous, homo means one. And so a homogeneous mixture is a mixture that looks like one thing, okay? Okay. Okay, so that's what a solution is. I know that we think of solutions as, answers to a problem, but in chemistry, a solution is just kind of like a mixture that looks like one thing. Okay, now this part I do need you guys to write down. A solution is made up of two things. It's made up of something called a solute and a solvent. Okay, so just make sure you guys write this part right here that I'm boxing. Okay, a solution is made up of something called a solute and a solvent. Okay, now I got the definitions up there, but there's a very easy way to think about this. A solute is the thing that's getting dissolved, okay? And a solvent is the thing that's doing the dissolving. Why are you changing seats all of a sudden? Okay, guys. So again, solute is something that gets dissolved. Solvent is something that does the dissolving. So very quick example that we can think about is salt water, right? So let's say this is our solution right here. Okay, let's say our solution is salt water. Okay, what is the thing that gets dissolved in salt water? Salt, right? Yeah, kind of a stupid question. So the salt would be your solute, and what's the thing that does the dissolving? The water, exactly. So that's the solvent. So just a quick, easy example for you guys to think about the difference between solute and solvent. And if you mix the salt and the water, you get your solution, which is salt water. Okay, make sense? All right. So we talk about solutions a lot in chemistry because as we do our future labs and stuff, when we mix chemicals together, a lot of times they're dissolved in water. It just makes them a little bit more stable and easy to work with. And that's why we're talking about solutions, okay? So we've probably heard of this word before, so I want you guys to write this down. Concentration. Now, it's not concentration like you guys focusing, right? Like you are right now. But in chem, concentration is how much is dissolved in something. Okay, so how much solute is in a defined space. Okay, so you can have higher concentration where you got more stuff dissolved, or you can have lower concentration where you have less stuff dissolved. Okay. Yeah, just the part that I highlighted right there, concentration. Okay, concentration is basically the amount of stuff dissolved in something. Okay. Okay, so higher concentration, easy way to think about it is something that is stronger, and lower concentration is stuff that's weaker. So I know that none of you guys are interested in alcohol, right? At all. But alcohol is an easy way to think about concentration. Okay, so strong alcohols, right, like vodka or whiskey, right, that would be more concentrated, higher concentration, because they have more alcohol inside a given space. But stuff that's less concentrated, like beer, has less alcohol in a defined space, right? So we kind of think of those as stronger or weaker, but it's the same principle. The more stuff you got inside a space, the stronger, higher concentrated it is, and the less stuff you have, the lower the concentration. Okay. But since you guys aren't interested in alcohol, things like drinks, like sugary drinks would work too. Like juice is less concentrated in sugar than like soda, which has a higher concentration. Okay. Does that make sense? Concentration higher, lower, stronger, weaker. Okay, so we're gonna go through a quick example. You guys don't need to write this part down, but let's just think about it. Okay, so I want you guys to take a look at these two solutions. I'll make them up here just so you guys can kind of visualize it. But solution one, we're gonna get 250 mils of water. Okay, so this much water, and I'm gonna put just 1 scoop of salt in it. Okay, and then for the second one, I'm gonna put 2 scoops of water, and I'm gonna have the same amount of water. I'm just gonna go to 250. Okay. All right, so between the two, which one do you think is stronger, more concentrated? The first one or the second one? Yeah, obviously the second. Why is the second one more concentrated? Yeah, it's 2 spoons, duh, right? So if we want to write that more, if we want to write that a little bit more technically, we can say solution 2 is stronger because it has more solute. Okay, 2 scoops of it, but you have the same volume, right? You got the same amount of water, but you got more scoops of salt in the second solution. Pretty easy, right? Okay, something we can all kind of think about. Okay, but when you start changing the volume, things can get a little bit more complicated, okay? So let's go to the second one. So instead, we're going to have the solution 1 is going to be the same. You still got 250 with 1 scoop of salt. But then for the second one, I'm going to raise it up to 600. And I'm going to put 1 more scoop of salt in there, okay? Okay, so which one do you guys think is more concentrated here? Solution 1 or solution 2? Okay, who thinks it's 1? 1 is more concentrated. Who thinks 2? 2 is more concentrated. And the rest of you guys are like, I'm not sure. Okay, this one is kind of hard to visualize. Does anyone want to test it? Anyone want to drink the salt water here? Yeah? I'll do it. Okay, Terry, you can come up here. And you can let them know which one is saltier, okay? All right, so this is solution 1 right here. It's salt water, so you don't need to drink. Take a little drink of that. Okay, that's solution 1. That's pretty salty, right? Super salty. Okay, and then solution 2. Let's see if you can tell the difference. Which one is saltier? This one? Solution 2 is saltier. Okay, maybe it didn't mix it correctly, but yeah. So this one gets really difficult because this one has more salt, right? But this one is smaller. Okay, and so that's why it gets a little bit tricky. So I want you guys to write this down somewhere. Okay, but the concentration, it's going to depend on the amount and the volume. Okay, so depending on how much salt there is, you can change up the concentration, but it also depends on how much space there is, right? The more water you have diluting it, the less salty it's going to be. Okay, so those are the 2 things you want to think about. Okay, just because this guy has more salt in it doesn't necessarily mean it's always more concentrated. Okay. Okay, but Marianne said the second one is more concentrated or tastes saltier. Okay, so that's it for the definitions and the stuff. We just have to write down our formulas and then we can start doing the actual problems and then we're almost done. Okay, we just have a couple practice and I'll get you guys started on the assignment. Okay, so this is the formula you need to write down, but the only part that you really need to write down is this one right here. Okay, just know what all these symbols mean. Okay, so capital M stands for molarity. Molarity is how we measure concentration. Okay, so the bigger the number for molarity, the more concentrated it is, the stronger it is. Okay, and then the way that we calculate it is going to be, we're going to take moles and then divide it by the liters or the volume. Okay, so just make sure you jot that down. And then a lot of times in chemistry, we're not going to be working with liters of stuff. That's just too much liquid. So we work with milliliters. So make sure you guys write that little conversion down. Liters, 1 liter is equal to 1,000 milliliters. Okay. So those are the only 2 things that we'll need for today. And then we should be able to finish all of our problems. Okay, so just make sure after you copy that down, you have your calculator out because we'll be using that to do our calculations. Alrighty, guys. So let's try number 1, and then I'll show you how to do that one, and I'll have you guys try number 2 on your own. Okay. Okay, so I'll leave these formulas up here for you guys. Okay, but in number 1, it's asking us what is the molarity of a 1.25 liter solution that contains 0.8 moles of AgCl2. Okay, so in this problem, we first need to figure out what we're looking for. Okay, so the question is asking what is the molarity. Okay, So molarity is going to be this capital M. So we're going to be looking for capital M in this problem. Make sense? Okay. So we're looking for capital M, and we know that capital M is equal to moles divided by liters. So if you can figure out how many moles there are, how many liters there are, you can find capital M. Okay, that's what we're looking for here. Okay, so let's look at the problem and see if we can figure out the moles, okay? So if we take a look at the problem, how many moles do we have in this solution? Yeah, 0.8, super easy. It's just right there, 0.8 moles. Okay, and then we're going to divide that by the liters. How many liters do we have in the solution? Yeah, 1.25. Okay, and that's it. All we need to do is plug into the calculator and we're all done. So basically what this is telling us is that we have a container. Okay, we have 1.25 liters. That's our volume. And then we have 0.8 moles of stuff dissolved in it. And that's going to give us our concentration or how strong the solution is. Okay, so if you guys remember the rules for fractions, it's just top divided by bottom. So on your calculator, you're just going to do 0.8, the top divided by the bottom, 1.25, and that will give us a final answer of 0.64. That's it, 0.64, and just make sure you label it properly. It's molarity of the chemical you're talking about, AgCl2, and that's your answer. Okay, so if you dissolve 0.8 moles in 1.25 liter solution, you'll get something that's 0.64 molarity. Okay. All right, any questions on any of those steps? Hopefully not too bad. You guys think you could try one on your own? Okay. I'll give you guys about 2 minutes to try number 2. You're going to be using these formulas up there, and I'll leave them up there for you guys to take a look at. So try to work with the person next to you. See if you guys can solve number 2 on your own, okay? And then we got a couple more before I get you started on your assignment. Got this one? Okay, so in this problem, same thing. We are looking for molarity, right? It's asking what is the molarity. So we're looking for capital M again. Okay, that means we just need to plug in moles and liters into the formula, and we should be good. So if we look at the problem, it says that we have 0.25 moles. So we can just put 0.25 moles on the top. Okay, and then we got 5.8 liters, so we can put 5.8 liters on the bottom. And then from there, super simple. We just do top divided by bottom, and we should get our final answer. Okay, so 0.25 divided by 5.8, and you should get 0.04. I'm going to go 0.043. If you got anything close to that, 0.04, 0.0431, as long as your number is close, you're good. Okay, and that's going to be molarity KBR. Okay. So if you guys got something close to that, you're in pretty good shape. Not too bad, right? Alrighty, so it's not going to stay that easy. It is going to get a little bit more difficult. And so let's take a look at some other problems that you'll see on your assignment, okay? Anyone still need this? I'll keep this up here for another minute. Actually, I'll keep it up 30 seconds and then we'll move on. Okay, so for the next ones, you're going to need your periodic table. So make sure you got a periodic table in front of you. Give you guys a second to take that out. Again, there's some next to the projector if you still need it. Alrighty, guys. Excuse me. Let's go to number 3. Okay, so I want you guys to take a look at number 3. I'm going to write down the equations that we had up earlier to see if you guys can solve this out. Okay, but I'm going to give you guys about 2 minutes to see if you guys can solve this problem on your own. Okay, these are the 2 equations that I had you guys write down. Let's see if you guys can solve it on your own. I'll give you guys about 2 minutes to try it out. And then after that, we'll go over it together. Okay, just make sure you guys look at the numbers in the problem carefully. Okay, but take 2 minutes and then we'll go over it, see if you guys got it. All right, so if we take a look at this question, same thing as before, we're still looking for molarity, right? So we're looking for capital M. So that means we're going to be using this equation right here. We just need to plug in moles and liters, okay? So lucky for us, moles is pretty easy, right? What's the number that we should put in for moles? Yeah, 1.2, right? It says 1.2 moles. So we're just going to put in 1.2 moles on the top, okay? All right. Now, we need to plug in liters on the bottom, but we have a little problem. What's our problem here? Yeah, it's 9,700 milliliters, right? That's not the same thing as liters. So what we need to do is we need to turn milliliters into liters. Now, we have this little equation that tells us 1 liter is 1,000 milliliters. If you guys are familiar with using that, you can, or you can just write this down and memorize it. When you go from milliliters to liters, you can just divide by 1,000. Okay, super easy. So if you guys take a look at the calculator, we can do 9,700 divide by 1,000. That means that 9,700 milliliters is equal to 9.7 liters. Okay, so just keep that in mind. If you ever see milliliters, you have to turn it into liters before we plug it in. Okay. And again, the reason why we use milliliters, it's not to annoy you guys. It's just because liters is a lot of liquid. And so it's just easier to work with milliliters. So when you do your labs in the future, you'll have to convert from milliliters to liters. And then we can plug that into the bottom of the fraction, 9.7 liters. Okay. Any questions about that, converting milliliters to liters? Just make sure if you see ml, just change it to L. Just divide it by 1,000, okay? Okay, so from there, we can do 1.2 divided by 9.7. It's the exact same thing as before, and we get our final answer. And then I'm going to write down 0.12. If you write 0.123, 0.124, that's totally fine. Anything around there is fine. And that's going to be molarity ZnBr2. Okay? Alrighty, you guys ready to try the last one? This is the last one that we do today, and I'll get you guys started on the assignment. Okay. Okay, so for the last one, we're looking for molarity again. So today, all we're doing is looking for molarity. You're just looking for capital M. Now, we can see that there's 100 milliliters, right? So what do we have to do with the milliliters before we do anything? Yeah, we want to divide it by 1,000 and turn it into liters, right? So I'm going to go to my calculator. I'm going to do 100 divided by 1,000, and that's going to give us 0.1. So we always want to make sure that we turn milliliters into liters by dividing by 1,000, okay? So that's going to be 0.1 liters. Okay, so that's the first thing you want to do. If you ever see milliliters on your problem, just make sure you turn it into liters, okay? Okay, now we go to our next number. It says that this solution contains 3 grams of salt. Now, this is already something different again, right? Because it says 3 grams. We want to work with moles, right? Because the molarity equation has us do moles. Okay, we're working with 3 grams of salt, and that's our chemical formula right here. Okay. Now, so what we have to do is we need to turn grams into moles. And the reason why we're learning how to do this is because if you guys remember from our previous labs, when you guys have a scale, right, and we put something on top of it, it doesn't tell us how many moles it is, right? It tells us how many grams it weighs. And so what we have to do is we need to know how to go from grams to moles. Okay, and I want you guys to write this down on your notes. Whenever you go from grams to moles, you always want to use your molar mass, okay? And if you guys forgot what that was, that's the numbers that you get from the periodic table, okay? So we need to find the molar mass of our chemical, which is NaCl, and then we could turn it into moles and then plug it back into this equation, okay? So just jot that down somewhere. Whenever you're turning grams into moles, you're going to be using the molar mass, okay? Okay, so let's find the molar mass of our chemical. We're talking about salt, and salt is going to be NaCl. So all we got to do is go on the periodic table, look for NaCl, and then we can find the molar mass, okay? So let's look at our periodic table. Let's first look for Na. Na is on the far right. Okay, Na is 22.99. So let's jot that down. The molar mass of Na is 22.99. Okay, so far so good on that. Hopefully not too bad. Okay, let's take a look at Cl now. Okay, remember we never use I, so it's not Ci, it's Cl. So if we take a look at the periodic table and look at Cl, what's the molar mass of Cl? Yeah, 35.45. So we're just gonna put 35.45. Okay, so Na is 22.99. Cl is 35.45. So if we want to find the molar mass of the entire thing, we just need to add them up. So I'll give you guys a second to add them up on your calculator. Let's see if we get the same answer. Okay, so take a minute, punch into your calculator. Let's see what you guys get. Okay, so you're going to punch in 22.99 plus 35.45, and you should get 58.44, okay? So that's going to be the molar mass of NaCl, 58.44, but remember, we got to write it the correct way, right? It's going to be grams divided by 1 mole, okay? So that's the molar mass of NaCl, okay? All right, so what we can do now is we can use that information to turn 3 grams into moles. So we're going to take our 3 grams that we had in the beginning, 3 grams of NaCl. We're going to set up a fraction. Hopefully this looks familiar, right? Okay, I have grams right here and I want to get rid of it. If I want to get rid of grams, where should we put it on the fraction? Top or bottom? Bottom, yeah. We're going to put grams on the bottom. And we're looking for moles. So we're going to put moles on the top right here. Again, we're just going to use the information from the molar mass to plug it in. Okay. All right. So what number should we put on the top of the fraction? Yeah, 1, because it's 1 mole, right? So we're going to put 1 on the top. And then what number should we put on the bottom of the fraction? Yeah, 58.44. Good. Okay. The reason why we do that is so that the grams disappear and we're just left with moles. And then we do the same math that we've been doing. We put in our starting number 3 divided by 58.44. And that's going to give us an answer of 0.05. I'm just going to do 51. Okay, and now we have moles. And since we have liters right here, we can find molarity. Okay, so we're almost done. Last step. Okay, so for the last step, again, since the question is asking for molarity, right? We want to find capital M. Molarity is moles divided by liters. So we're going to take the moles that we found, 0.051. We're going to divide that by the liters that we found right here, 0.1. And then that's going to give us our final answer, which is 0.51 molarity. And there you go. That is about as hard as it's going to get today. Okay, so your final answer is 0.51 molarity. Now, if you guys notice, I know we spent a lot of time doing the problem, but we only did 2 things. We used the molarity formula that we learned today, and we did molar mass, which we learned in the previous unit. So like I said at the beginning of the year, if you start falling behind, it's going to be harder and harder to catch up because everything kind of comes back and we're going to be using it again. Just a heads up for the future lessons. You guys remember stoichiometry that you guys spent so much time practicing? We're going to be using that with the molarity formula. So just remember, if you fall behind, it gets harder to catch up. So make sure you come to me, ask for help if you guys need it. We do have tutoring during lunch if you guys need it, and the lecture videos are all still up on Canvas. So just make sure you guys use those resources. But that's pretty much it for today. I'll give you guys the rest of the class period to work on your assignment. So if you guys go to your assignment on Canvas, there's going to be 2 parts to it. Only do part 1 for today. We're going to be going over part 2 next time. So you're just responsible for part 1. Okay. Other than that, I'll give you the rest of the class period to work on part 1 of the assignment. If you guys have any questions, if you want to check the answer key, please come see me and I'll be more than happy to help you out. But you have the rest of the class period to finish up your work.